What's up, guys? Good to see you. Good afternoon. Right now, when I'm recording this, it's Friday, so I hope you had a great weekend. While you're watching this, it's Monday. I'm at a meeting. I'm sorry, I missed you guys. I'll see you tomorrow. But you guys got a good amount of work to do today, so let's be on it, and let's get right to it. Quick reminder, we talked about something very important on Thursday. We came up with this list. That's not yet, right? Remember how you should act when there's a sub here. Some of them are the same as when I'm here. Some of them are different, right? I'm going to hang this. This will be hanging on the front whiteboard just in case you happen to forget. But this is how you should act, and the sub knows that you know this is how you should act, all right? Now for this video, I'm going to put it behind me. And so, as you watch, if you maybe forget how you're supposed to act, you can look right here, all right? Okay, let's get going. This is your do now for today. You do not need a purple slip. I just want you to think. So take about 10 seconds of private reasoning time, just some think time. 10 seconds, and think of answers for these two questions. Three, two, one. All right. Now, before we go any farther, there we go. As sometimes, I'm going to need to give some directions, and you might need some more time to think or time to move around and get ready. So in those cases, I will hold up this sign that says pause video, and at that time, either maybe one of you want to volunteer or the substitute can do it. When I hold up this sign, pause the video, and then do whatever instructions that were given. When you're finished, resume the video, and we can keep going, all right? So, just because I'm gone doesn't mean we're going to start class any different. So, class, please pause the video and time to check in. Let's check in. Okay, thank you. Let's get going. Today, we're going to look at a small little topic that some of you may be familiar with, some more than others. We need to become a little more clear about the laws of exponents. It's going to be real important with what we're going to do moving forward. It's related to what we've been doing recently, but we're going to be real specific today. So here's the agenda. We're going to do kind of a worksheet together where we'll pause and you'll work, and we'll come back and then pause and work and come back. We'll summarize with some notes in our binders, and then you're going to have a graded group task at the end. I will explain those directions when we get there. Notice we got a quiz tomorrow. It'll be on distributive property. Quiz tomorrow. Okay. You should already have your binders, but grab out your binders, open to the table of contents, and in a second, pause. I'll tell you to pause in just a second. Add this into your table of contents. You got about, let's say 3 minutes. Come on, 3 minutes for this, really? You got 2 minutes to make this happen. Binders and table of contents. Pause the video now. All right, we're back. Okay, you should have your notebook set up like this. Open to the next spot. We'll either substitute. Now you can hand out this paper or hand it to someone to hand out. Each person should get this paper. It's kind of gray. It got copied a little weird. It is not that one, not that one, not that one. This one. All right, Exponents Expedition. If we need to pause to hand those out, pause now. Okay, let's go. Leave this out of your binder right now. It'll be easier to write on, okay? So we're going to deal with exponents. Let's start up here at the top. Let's review what an exponent means. Exponents are a way to show repeated multiplication. So for example, 2 to the 5th power, that's how you say it, not 2 5, 2 to the 5th power represents 2 being multiplied by itself 5 times. 1, 2, 3, 4, 5. Okay? Now we're going to keep that idea in mind. This first row in each of these has an example, and then I'm going to give you some time to use that example to fill out the other rows, and then we'll come back and look at the answers together, all right? So the top one on this first page has an expression with some numbers, and the ones down here at the bottom have variables. Let's look at what happens. 2 to the 3rd times 2 to the 4th. So here's your 2 to the 3rd, 2 to the 3rd, right? 3 2's times themselves, times 4 2's. Well, how many 2's are there? Count them up. 1, 2, 3, 4, 5, 6. There's 7 of them. So if there's 7 2's being multiplied by each other, that's 2 to the 7th, all right? So now, use that example, use some critical thinking, and I want you to go down to this next one also. You got about, substitute, will you please, substitute teacher, look at the clock. Give yourself about 10 minutes for this first page, and we'll come back and look at answers, all right? 10 minutes, pause the video now. Okay, we're back. Let's check out answers. Up here. 3 to the 4th times 3 to the 1st. Well, that's 3 times 3 times 3 times 3. There's your 4 3's. And then you've got times 1 more. Well, that's how many altogether? 5. 3 to the 5th. And I think if you did that correctly, this should be 7 to the, not 16, to the 10th. To the 10th. And this one, this last one, even though they're variables, x to the 10th, right? You got 3 here and 7 here. So now we're going to generalize that a little bit. What if all of them are variables? Well, how did you get 7 and 5 and 10 and 10? You added the exponents together, right? So even though we don't have numbers, we can write this as a, because they're both have a base a to the m plus n, right? That would be the algebraic, more abstract way to write it. Now, does this apply to the expression 4 to the 3rd and 5 squared? No, it doesn't. Why not, though? Well, look at what it means. 4 to the 3rd would be this, times 5 times 5. Oh, not 2. 5 times 5. 5 squared. What's different about that than the ones we did before? Those are different bases, right? Different numbers. It's not that we have 5 5's or 5 4's. We can't combine them together. So this is just, you can't combine them up. Sorry, my phone's going off. Turn your phone off right now. Take out your earbuds. Oh my gosh. It's my wife texting me. I'll slide it over here. That's my bad. All right, let's keep going. What about these? Well, just because there's more than one thing in the parentheses, exponents still work. It means whatever is raised to that exponent, you multiply it that many times. So for this one, you'd have 2 times 5 3 times. 2 times 5 and 2 times 5. Now, yeah, we could make these all 10 times 10 times 10, but we're looking at exponents today, right? So let's rearrange some stuff. You guys know, like 2 times 3 and 3 times 2, those are the same thing. You can move them around. Well, how many 2's do we have being multiplied? 3 of them. And how many 5's? 3 of them. So to write them all shrunk down, 2 to the 3rd and 5 to the 3rd. Right? That kind of looks like distributive property, doesn't it? It's related, it's not exactly the same. So what about this last one? A, B to the M? Well, A to the M and b to the m. All right? Now look at this key question. Is this and this the same? No, it's not. Let's prove it. X, y to the third. Is that the same thing as xy times xy, times xy? There's 3 xy's. Xy times xy times xy. Well, how many x's are over in this one? Just one. How many x's are on the other side? 1, 2. Yeah, 3 of them. So if you got 1 x on one side and 3 on the other side, no, they're not equal. There's 1 here and 3 there. So no, they're not the same. And this math proves it. Okay, turn the page. These may look similar, but they're actually a different rule. Okay? This is the end of this video, but you still have, look at the clock. Give yourself, let's say 12 minutes this time for this side, since I'm going to let you just kind of figure it out on your own. Talk it through, look at the pattern and the examples. 12 minutes. Fill out these 2 that are on this page. So you got 2 that are on this page, all right? You got 12 minutes. You may begin. We'll come back with our next video in just a bit.